Hello and welcome to this video on standard deviation. Today we're going to take a look at standard deviation. So the first thing we're going to do is just kind of talk about what standard deviation is. So I usually will write SD for standard deviation. And so really it's going to be the variation in our numbers, in our data set numbers. So variation in data. Okay. And what we know is that the lower our standard deviation is, the greater our precision is. And so we really want to have low standard deviation. And so when we're doing our labs, this is one of the ways that we can actually take a look at our data and evaluate how well we've been doing. So we're going to use the equation standard deviation is equal to the square root of the sum of xi minus x bar squared, okay, and the squared is within that, divided by, and in our case we're going to use n. This is if we're actually working with a whole population or a whole set. We have all of our numbers, so they'll say whole population. Okay, there's another one that we could use if we're using just a sample, and so sometimes there's times where we'll just have a sample of the total data. And in that case, it's going to be the same setup up top, but it's going to be n minus 1. And so this is if we're working with a sample of the population or a sample of the total data that we could have. Okay, so don't just think of this as populations of individuals. So we probably want to know what all these mean. Remember that this sign means the sum of, okay? Xi is actually going to be individual data numbers. X bar is going to be the average or the mean. And then n, I'm running out of room here, n is going to be the total number of data points. So we're going to take a look at an example of how we can actually do this by hand. And so here, say, is our group data. So we're going to have our group data, and this could be for multiple trials. So we'll have our data, and say our numbers are going to be 10, and I think I did 10. Let's see, what else did I have? A 9. A 7 and another 10. Okay, so this is going to be in our table, and we want to actually be able to do something with these. And so we want to know what our average is first. And I always like to get that average first here. So if I calculate the average here, so I add all these up and then I divide by the total number that I have, which is 4. Okay, so we already know that the total number of data sets is going to be 4 in this case. Then we end up with an average of 9. Okay. And so what we're going to do is we're going to take, and so all of these data numbers are our xi's. So xi is going to be our data numbers. So we're going to have, oops, excuse me, let me go and erase the 9. We don't want that there. We're going to have 10 and 9 and 7 and 10. So those are our data numbers. And then we're going to subtract from that our x bar. Okay, and so that is going to be our average. So we're going to subtract 9 from each one of these. Okay. And when we do that, we're going to get a 1 here and a 0 and a -2. Okay. And then in this one, we're going to get a 1. Now, for this one, we're going to take this and we're going to square this number. So whatever's in here, we're going to square it. So I'm going to square each one of these. And so I should end up with a 1, a 0, a 4, and a 1. And then what I do is I find the sum of them by adding all of these numbers up. And so when I do that, I should get a number 6. Okay? And so really, that's how I did the top part of our equation. So if standard deviation is equal to the sum of all of those data points squared, this is the part that we just did. Oops, xi minus x bar squared. So we did the top part of this. Now what we want to do is we want to divide that by n and then take the square root of it. So I end up with this. I'm going to have the square root of 6 over, we had our n was 4. Okay, so if I do 6 in my calculator, I'm going to do 6 divided by 4. And then I want to take the square root of that. So I end up finding out that my standard deviation is around, let's see, what was that? 1.2247. Okay, and so then I would use this number. Now, what does this actually look like when we're taking a look at some sort of a chart? So say I have a chart here, and we're going to make something arbitrary. So I did this before as an example where we do our percent composition lab with bubblegum. And so say that we had our percent composition of sugar and flavoring with different brands of gum. Of chewing gum. And so on this side, we're going to have our average percent composition. And down here, we're going to have our types of gum. And say we have double bubble, and we have 5 gum, and say we have Orbits. Okay, I'm not promoting any gum, I'm just making a few of these up. So say double bubble, we had the percent of those ones was here, and then for our 5 gum, maybe it's here, okay, and then maybe Orbits last the longest. I don't know what it would actually be. We would have to go and actually test this. Okay, so it's going to be a little bit less here. Now, what starts to happen is when we do our standard deviation, so these are our averages, we actually will put these on a graph in using error bars. And so this half of the error bar from our average up is going to be the amount plus the standard deviation, and this part is the minus standard deviation because it's always plus or minus. And so we see this is the variation in our data numbers around that average. And so we might have that, and then say we have this one, okay, and then we have this one. Now, if our error bars actually overlap, which we see all of these do, then we say that there's no statistical significance. So if error bars overlap, there's really no statistical significance. So we may see that there's a trend, but you know what? It might not be statistically shown to be really significant, and so we can't say because our variation in our numbers is so big. But if you were to have error bars and there was no crossover, then we know that they would be statistically significant, and that's something we can talk about a little bit more with specific labs. Okay, so the other thing that I wanted to do is show you how you can actually do this in one of the Google spreadsheets. And so I actually have some data already up here. And what I've done is I've entered in some numbers, and so I want to show you how you can actually do this in here. And so we have all of our numbers, and if I want to do an average, and this works very similar in Excel, you can actually do some of these in Excel. So I'm going to do average, And you guys actually get Google spreadsheets because of the way that I actually enter in data, or we enter in our Google Forms. So I can either average this one as well, but since I just did that, I can actually have that one go over, and it will give me the same, it'll do the same thing. And so there's some tricks that you can use in these. And if you guys get to this and you have some questions, please let me know as you're working in your spreadsheets. Now, their standard deviation doesn't show up when I just hit this. And so what I want to do is usually I hit the equals and then I do ST. And so we can see just standard deviation. We could just use the regular standard deviation. It will give us standard deviation of an entire population, text as 0. There's all sorts of different things that we see come up, or standard deviation of entire population. Any of those would be probably fine for what we're doing in class at this point. So I'm just going to pick the regular standard deviation, and I'm going to highlight my data points without my average, and I hit enter, and I see that that's my standard deviation. Now, if I don't want to do the whole thing again, I just click on that little bar there and I bring it over. So now I actually have a couple numbers, and what I want to do is I want to write these down. So I have 1.4397. I'll round that for my first one, and then for the second one, 0.9304. Okay. And so we want to put custom error bars onto our graph, but we don't want to actually highlight those. So if I go to create a graph in here, or a chart, I'm going to go into my charts, and I'm going to pick a bar graph in this, or a column one in this case. Okay, and I see this here. What I can do is I can go in and I can customize, and so there's this customize setting right here, and I'm going to customize this. I can go in and do some other stuff later with some of my columns and chart title and all of that stuff, and my axes. So what I'm going to do here is I'm on column 1, which is series 1, and that's my blue color. I can change the color if I want. I don't need to. But down here it says error bars, and I'm going to end up creating this as a constant, and then I'm going to plug that number in that I had. And so I had 1.4397. Okay. And I don't want to insert yet because I actually want to go to my other series, my column 2, which is this one here, and I want to do the same thing, a constant, and it automatically gives me 10. I don't want that, and I want to have that be 0.9304. Now once I have those both in, then I can put them in, and oops, let me see where that went. And so here is my data, and we see that there's no crossover in those error bars, and I could go in and do some more editing. I'm not going to do that for right now. But that gives us an idea of how good our data numbers are, and as we are working in our individual groups, or as we're taking a look at whole class or whole section information, that'll actually help us to evaluate how well we've done on our labs. I hope this is helpful for you. Let me know if you have further questions.